Okay, we are looking at states of matter, and by the end of this lesson you will be able to tell me what the 3 states of matter are, the properties of each state of matter, and the name of the changes of state. Okay, now scientists for years and years and years have used models to represent atoms and to be able to understand and make predictions about substances. In one model, you can think of atoms as being small solid balls called particles. Okay, now you can use a model, simple models, to represent the 3 states of matter. And the 3 states of matter are a solid, or solids, liquids, and gases. As you can see here, the solid particles are all touching. Okay, they don't move, but they do vibrate. Okay, and they're arranged in a regular pattern. Particles in a liquid, they're still touching. Okay, so this is a liquid now. They're still touching. Okay, but they're not arranged, as you can see, in a regular pattern. Okay, and they're free to move. They can move. Okay, not free to move, but they can move. Yeah, they take the form or the shape of the container or the surface they're on. Now, gases. Okay, so now we're at gases, right here, gases. Now, particles are moving fast in all directions, and they're not touching. Okay, there's lots of space between them, and they're not touching. Okay, so those are the 3 states of matter with some of the properties of them. Now, changing state. So it is possible for substances to change state. So if you change the temperature on a substance, or change the temperature of a substance, you can cause a change in state. Okay, now changing state is a physical change. Okay, and that basically means that no new substances are formed. So a really good example of that would be water. Okay, so water can be frozen into a solid. Once it starts melting, okay, it turns into a liquid, and if you apply more heat to it, it starts to heat up enough that it starts to turn into steam, which is the gas form of water. Now, a couple of things we need to talk about. So we're looking at a melting point. I mentioned it a moment ago. So melting point and boiling point. So basically the melting point is where it can a substance either melts or it can freeze. Okay, so that's the melting point. Okay, that's the point where those 2 things could take place. So melting happens when a substance is being heated, okay, and the particles in a solid start to be able to move around, but they're still close together, and that's when that substance becomes a liquid. Now, when the freezing point, or when we're talking about freezing, so freezing happens when the substance is being cooled, okay, and particles in the liquid stop being able to move around and they become arranged in a regular pattern. And that's the process of it, a liquid turning into a solid. Okay. Now, boiling point. So boiling point is where it can, a substance is either boiling or condensation can happen. Okay. Now, boiling happens when a substance is being heated. Okay, a bit like what we said talking about melting point, but this is where it's being heated and the particles in the liquid, they start to move apart from each other. So they start to move a bit about more freely, and then they start to move around more quickly, and that's when a substance becomes a gas. Now, condensation happens when a substance is being cooled, okay, and the particles in the gas move closer together, okay, so that they start to touch or are touching, and they stop being able to move around very quickly, okay, and that's the process. That process is where the substance becomes a liquid. So talking about pure substances, so pure substances have a very sharp melting point and boiling point, okay, so these are temperatures at which a substance changes state. The particles in a solid, liquid and gas are held together by forces, okay? And the stronger the force between the particles, the higher the melting points and boiling points will be. Now, so we're talking about substances with high melting points and boiling points have strong forces. So substances that have high melting points and boiling points have very strong forces that hold the particles together. Okay, now substances that have very low boiling points and melting points, okay, is the opposite. Okay, so they have very weak forces, okay, holding them together. Okay, so that's why they have a lower melting point and boiling point, a bit like ice. And we're going to have a look now at a demonstration proving that point with water. Okay, hope you enjoy it. Here we go. Okay, as I said earlier, the three states of matter are solid, a liquid, and a gas. And a great way to demonstrate that is by using water. Okay, so water is a really good way of representing this because it can be in the form of a solid, a liquid, and a gas. Okay, the solid form of water is ice, and obviously the liquid form is water, runny water, and the gaseous form of water is steam. Okay, it's where the water starts to evaporate once it starts to boil. Okay, so it starts turning into a gas. So here we go. I don't know how long this will take, but I'm going to add, so I've added some heat from a Bunsen burner. I'm going to put a few ice cubes in, and hopefully we'll be able to see that in a mo. Okay, so as you can see, the heat is has been applied. Okay, and what we should start seeing is a change from solid to a liquid with water. So if you can hear that, it's starting to heat up. Okay, and if you can just see, there is liquid forming now, so liquid water, okay, from the solid ice. I won't be able to pick that up in a minute. I won't try. Okay, so yeah, so as you can see, the solid ice water is now melting, so it's found its melting point. Okay, we found the melting point, and it is turning into a liquid, so it's turning into liquid water. Out of interest, be really interested to find out in the comment section what is the melting point of water and also the boiling point of water. So put those in the comment section, please. Okay, so as you can see now, we've got quite a bit of water, liquid water forming. Okay, and we should start seeing the ice cubes completely go in a moment. In fact, let's take a few out, speed the process up a little bit. Now we're at the temperature, the point in temperature where it starts to melt. Okay, so now we've just got water in here. Okay, as you can see, water in there. What should start happening then to this water as it's heating up more? I think hopefully you can start seeing some bubbles forming. Let's have a look. So yeah, let's have a look. You might be able to start to see the bubbles there forming. So what that means is the water now is getting to the point where it's starting to boil, and we're starting to reach its boiling point. Let's increase the temperature a little bit more. So we're now on a roaring flame. Sorry if this is boring. So when water starts to boil, what starts to happen? That's what you need to start thinking and observing now. So water's starting to boil. Bubbles are forming in the liquid water, which means it's starting to boil. Okay, here we go. You can see that now. So lots and lots of bubbles are appearing. It means the particles are starting to gain energy and starting to heat up. and then you can see here some steam coming off the top. Now, to prove that when gas or steam starts to cool down, it starts to condense. In fact, let's use our other beaker. Okay, see what happens. So as you can see, steam's starting to steam up the other beaker, and as the steam rises, it loses some of that temperature it gained from being heated up, and it starts to cool down, and it then, so when steam starts to cool down, it turns back, I don't know if you can see that, turns back into a liquid, so it condenses, it cools down and turns back into a liquid. Okay, so remember, 3 states of matter: solid, liquid and a gas. Really good way of demonstrating that is by heating up an ice cube. Okay, and what you'd be able to do there is obviously you can reverse the process, so steam turns back into a liquid once it cools down, back into water, and if you cool it down even further, you can turn it back to ice. All right, hope you found this interesting. Let me know what you think. See you later.